Hypercard in the World was a live programming environment for the real world. It was a kind of operating system for programs running on real-world objects. In the system, you could point with a laser pointer to the four corners of any physical thing to bless it as a programmable object. You can now write code that runs on that object and interacts with all the other objects in the space. With Hypercard in the World, we could start asking questions like, what is it like to read a book while seeing the entire book at once? Or what is it like to watch a video with an interactive poster that shows the entire video at once and lets you navigate freely around it? What is it like to browse all of the past projects from everyone in the group in the form of an interactive searchable poster gallery? What is it like to make interactive dioramas together with other people or to paint on the wall? Hypercard in the World was, to a certain extent, implemented in itself as a large interactive poster in which you see data flow in real time and can live modify both the code and the data on the poster itself. In this video, I'll give some of the backstory leading up to the creation of Hypercard in the World, and I'll go into some detail about the various projects that were made in it, including some of the games that were made at our 3-day game jam, and I'll show how the system works via BigBoard, which is the implementation of the system in itself. This work was done in early 2015, and most of the demonstrations you'll see here were recorded in 2016. I'm editing this video right now from 2024, so I'll conclude with a bit about what happened after this project. It led to a subsequent system called RealTalk, which led to a place called Dynamic Land, and those projects are still very much active. The Communications Design Group was started in 2014, a research lab charged with inventing new computing systems to support fundamentally new ways of thinking and communicating. In the lab's first year, we published a number of screen-based works in which the reader was surrounded by rich context or directly manipulated explorable models. But our primary interest was not computers, it was how ideas could be represented and communicated, and in order to get real context and direct manipulation, we also found ourselves designing many things that were not in computer screens and couldn't be. Here's a passage from a Bruno Latour essay redesigned as a 6-foot poster comic whose structure is visible from a distance away. Here's the table of contents of Neil Gershenfeld's book on mathematical modeling, as a kind of toolbox poster that you can browse when you need a mathematical technique. These are a couple examples of spatially represented text. There's also a lot of interest in spatially representing video. This huge poster shows every frame of the film Hemingway and Gellhorn, and that led to many subsequent posters showing every frame of video, exploring various designs and organizations. Here's a talk that I had given redesigned as a poster comic whose structure is browsable and readable at different scales. This is an earlier talk as an interactive poster. It has 8 iPads embedded in it, one for each chapter, and you can scrub through the video by sliding your finger along a touch-sensitive strip of thumbnails below. Here's a binder where every page represents a video, and you can navigate through the archive by turning the pages. And another book where, as you turn the pages, key passages highlight and related video plays. Here's a representation of all the pages of a book chapter, which you browse by moving your body left and right. Here's a book that generates physical receipts as you browse Wikipedia and conversation. These receipts were taped up on the wall, providing a spatial record of past conversation. Going beyond flat paper, this is a diorama timeline, a 3-dimensional timeline of the key events in a particular book to be glanced at while reading in order to maintain context. And a similar idea is suspending the timeline above the reading area in a hanging mobile. These sculptures are 3-dimensional plots of mathematical functions. And this is a stretchy sculpture of a brain scan. So within the group, there was a lot of interest in how ideas could be represented and communicated outside the tiny rectangle of the computer screen. The origin of Hypercard in the World was, in fact, a poster gallery. We wanted to make a gallery of our past work, where each project would be a label on a poster. It was Glenn who expressed the wish that the label could somehow link back to the project documentation, and we had the idea of pointing at the label with a laser pointer. That evening, Robert already had a prototype working, and from there we were off, and the first iteration of Complete Programming Environment came together in a couple weeks. What I want to emphasize here is that Hypercard in the World and subsequent systems started with media and then added computation. Many other projects take computers as their starting point and then try to force-fit computers as they are into some sphere of human activity. They try to make media out of computers. This project started with posters and dioramas and spaces. It started with forms of spatial media that already work really well and fit well into a human environment. Hypercard in the World lightly augments these physical media with computation to help them better express context and dynamic behavior, but their essence is still posters and dioramas and spaces. I feel like one of the most important parts of understanding is seeing context. So if you want to understand a thing, it's not enough to just see that thing in isolation. You really want to see the entire space of things and where that thing kind of fits in the big picture. And one of the nice things about getting outside the tiny rectangle is that there's all this room to show that kind of context. So one really simple example of that is if you're reading a book. So when you're reading a book, you can only see the page that you're on. And that sounds really obvious, right? But this book is 100 pages. So the book is this kind of very large, detailed structure. And when you're reading, you're kind of looking through a pinhole. You can only see a little bit of it at once. And you kind of have to keep the larger structure in your head. And when you're reading on a screen, it's even worse, because here you have much less sense of where you are in the structure. You're much less physically grounded. So on a screen, it's much more of just kind of one thing after another after another. So we thought it might be interesting if you could be sitting on the couch, flipping through a book, and you can always glance up there, say above the shelf, and you see a map of the entire book, right? So the big blocks you're seeing up there are the chapters in the book, and you're seeing every page in every chapter. And there's one page that's kind of popped out, and you'll notice that as I flip through the book, that marked page is kind of going along with me. So at any moment, I can just glance up and I see exactly where I am within the chapter and exactly where that chapter is within the entire work. So when you're reading, in your periphery, you're always seeing what came before, what came after. And so that's one of the things that a map gives you, is that it lets you stay grounded. Another thing that a map gives you is it lets you move around really freely. So say I'm on this page and I see this figure, and this reminds me of a figure that was over in the previous chapter. I can see it's the green one, right? And I'm going to take a peek at that. So I can take this laser pointer, it's just an ordinary laser pointer, and point over to that figure, or over the page, and now I'm on that page, right? And I can go back to where I was, or I could say what he's talking about here, I like how he summed that up near the end of the book, right? Oh, but his summary here is, maybe that contradicts what he was saying over here in this chapter. Let me jump over to that. And so you can move freely around the work as you make associations in your head, right? The connections that you make kind of knit together this larger work. You're not trapped in this kind of linear tunnel vision. So what you're seeing here is a page within the chapter and a chapter within the book. But there's this other space of information here, which is the book within the shelf. This is also a kind of map of knowledge. And maybe we want to do the same thing here, that we can point to a book on the shelf and it lights up and we see a map of that. This is Computer-Lived Dream Machines, which doesn't really have chapters. But next to it is a early Whole Earth catalog, because I wanted to see what those pictures would look like. And then next to that is a monster 450-page Whole Earth catalog, because I wanted to see what this design would look like with so many pages. So you can see what we're doing here is not just pointing to virtual objects rendered on a screen, but we're also pointing to real physical objects, meaningful physical objects in the real world. And that's going to become really important. So this is one way of drawing the map of a book. And we went through a number of different designs for that. So one we started with was this one, where you take all the pages of the book and kind of blend them together in this kind of smush. And that was interesting, but then I thought, okay, well, maybe we take this page and shrink it down a little bit and lay them out on a grid. And I thought, okay, that needs more structure, right? We want to be able to see the chapters. So in the next design, the chapters are these long strips of thumbnails, and they kind of highlight so you can always see what chapter you're in and where you are in that chapter. And then I started getting into columns and saying, instead of running the thumbnails all the way across, maybe each chapter has its own little column, and then the thumbnails wrap around in there. So I'm showing you these different designs by pointing over here on the whiteboard. And these are literally just boxes I drew on the whiteboard with whiteboard marker. And I kind of even annotated them. This was March 2nd, this was March 9th. I just kind of scribbled that on there. The code that's drawing these maps up here is inside this box, at least conceptually. And so this is kind of a hint that what we're showing here is not some specialized installation for drawing pages above a shelf. I'm actually standing in a kind of room-sized authoring system for creating dynamic spatial media. So there's a kind of operating system which is running the entire space, which we've nicknamed Hypercard in the world. And the way it works is you start with real physical objects, such as a box on a whiteboard, or a book, or a wall. You point at the four corners of that object and you bless it. And then once the object's blessed, now you can write code that runs on it. The object can see the other object, communicate with them, draw on them, and whatnot. And I'll talk a lot more about authoring at the end, but I want to give you a little preview of how this works because I'm going to be showing other projects made in the system, and I want you to see that it's not really magic. So this object right here, I can inspect it by pointing to it and hitting the inspect button. And so you can see that that object has a few things. It has an identity, which gives it a name. It has a location, which says where it is. And it has a little bit of code, which is what's drawing that map above the shelf. And I could change that code, or I could maybe do something more interesting, which is say, I want to make a variation on that. So I'm going to draw my own little box on the whiteboard, like that. And then I'm going to duplicate the object I'm inspecting onto this new object that I just drew. And I was a little sloppy with the blessing there, so I'm going to tighten up the corners a little bit in the inspector, and that's good enough. And so now we have this object and this new object right now are both drawing the same thing, but maybe I want to change this. So the selected page there is right now being drawn kind of popped out, and I might say, actually, I want to draw that a little bit differently. Maybe I want the selected object to be drawn as kind of a red border. So I can make the changes to the code to do that. And I'll hit save. And so now you see the selected page is being drawn with a red border. And on the old one, it's being popped out. So now this guy's drawing it differently. And there's nothing magic about this particular whiteboard. I could, for example, I don't know, take a sticky note and I could put it anywhere in the room, right? And then I can duplicate the object that I just made onto this sticky note. And so now it's the sticky note that's drawing that map up there. I can switch to that view, or I could select this object, and now it's drawing it. And there's more to this than sticky notes and whiteboards, and like I said, we'll get to that in a bit. I'm showing this because I want to emphasize that what we're working towards here is not some app that people download that draws stuff in their environment. What we're working towards is a medium that enables people to create these sorts of things for themselves, for their own needs, in a way that makes sense for their own environment, for their own context, right? So in the same way that if I give you a piece of paper and a pen, you can draw or write anything that you know how to. We want to work towards a medium where people can create dynamic spatial media for what they want to do in their own environment. And then that medium has to be paired with education and a corpus of really, really great examples so people have good ideas of what to make. So this is a talk that I gave a couple years ago, and you can go to Vimeo and hit play, and stuff will happen at you for 20 minutes or so, and then you'll walk away thinking, okay, that was entertaining, but what did I just see, right? Because a video is a very ephemeral thing, that you can't see any larger structure. It's just kind of one thing after another after another. There's nothing really to hold on to. So I redesigned this talk in the form of this poster comic strip. And the text here is the talk verbatim, so you can just start at the top and read your way all the way to the bottom. But you can also see the larger structure. So from 20 feet away, you can still see, okay, there's the purple section, the blue, and the green. And as you get closer, you see the subsections, you start to see the pictures, and when you get all the way up to it, you can start reading in depth. So it allows for this kind of variable level of detail, which lets you skim, you can browse, you can get a gist at a glance. All these things that are normally really hard to do in time-based media. The poster is also a physical object in the world. It's persistent. We walk past it every day. And so that means that these ideas that are embodied here, they have a physical home, they have a location. So we can be anywhere in the lab, and if we start talking about these things, we have somewhere to point to, or we can walk over here. It has a very different feeling than ideas that you've only seen kind of pop up on a computer screen and then go away. So this is a nice map of video, but it's not video, right? Like in video, you can hear somebody talking, you can see the animation. We don't want to lose all those things. So what you can do is you can take this laser pointer and point to a panel, and it highlights, and then you see the video starts playing on the far wall. And as the video plays, you see the highlight is kind of moving from panel to panel. So this is your playhead, but unlike a normal playhead, it's in a structured space where you can see you're in this section, you can see what came before, you can see what came after. So like the map of the book, it lets you stay grounded. You always know where you are. And also like the map of the book, it lets you move around. So if what you're hearing here makes you think of something that was back here, like, okay, now you're back here. Or you can jump ahead. You know, you have the freedom to move around the work as you make associations in your head and as you make connections. You're not trapped in the author's kind of linear narrative. Something interesting came up here from a UI perspective when we were making this. When you're reading the poster, you're normally pretty far close to it. You're pretty up close to it because the text is kind of small, right? And then if you start playing the video from some point, the video starts playing, but it's mostly occluded by the top of the poster, so you involuntarily take a few steps back. And then without even thinking about it, you've now positioned yourself in a place where you can see both the entire video and the entire map in your field of view. And they're in the periphery of each other. And you switch between looking at the video and the map by refocusing your eyes to a different plane. And if you've ever struggled with UI designs where you're trying to cram a whole bunch of context on a computer screen, and you've got detail views and overviews and affordances for switching between the two of them, you know, all of that kind of fighting over screen real estate stuff just becomes irrelevant when you can use services in the real world, and readers can look between them, switch between them by just kind of looking at different ones or moving their body around. I want to show a quick peek of how this is implemented, just to show that there's not really any magic happening here. So the poster is a blessed object, right? I just pointed to the four corners and added a little bit of code to it. And the individual panels are also objects, and there's really not much to them. Basically, I just gave them a name, which was their timestamp. And then the poster has a little bit of code that says, when one of my children is selected, tell the video player object on the far wall to start playing from that timestamp. And you'll notice that the big panel right here isn't doing anything yet because I haven't bothered to hook that up yet. So I'm going to do that now. I'm just going to point to the four corners, like so. And I need to give it a name, which will be the timestamp that we want to start playing the video, which is, I think, 6:04. And now when I select that panel, the video starts playing from that point, and it's just another panel. This is our research gallery. So this is the kind of meta project which lets us get to all of our other projects. So these posters here are just pieces of foam core that are hanging from the ceiling. And these are printed out sticky labels that represent the different projects that we've done over the years. So where this came from was, as a research group, we develop our ideas by making lots of little prototypes. So you might make your project and send it out on the email list, and someone else might see it and kind of riff on it. And there'll be this kind of flurry of activity around an idea for a little bit. And then a few months later, it's just totally forgotten, right? Because it's buried in the bowels of your email. You never see it again. Email is this very ephemeral thing that just kind of flashes by on a screen and goes away. And so we're trying to think of a way where we could surface this work that we've worked on and give it this kind of more persistent physical form where we can see it and walk past it every day. So now what we do is we send out our email just like normal, but then come over here and laser the spot on the ground that says design a label. And the email list comes up over here, and you'll just click on your email, and it designs a label. You hit this button that says Print Label. And so a sticky label comes out of the printer here, and you just take this label and stick it on the next open spot on the poster board, like that. And then the last step is to bless that label that you just put there. So in the inspector, you point to the four corners, and you can be a little sloppy because the poster will snap to the grid. And I added a design attachment, which basically just tells it which label it is. And now, when I point to that label, the project comes up over here on the screen. And I can point to any of these things, right? And they come up over here. And so this is a kind of map of the work that we've been doing over the last couple of years. And visitors can come in, and we can come over, and we can see everything that we've done in context. And it doesn't matter whether the project is, say, from 2 years ago, like Glenn's project here, or if it was something just from last week. Everything is just kind of one point away, and we can make these connections across time. So what you're seeing on the screen here, when I select one of these things, over here on the left is the prototype or the video or whatever it is the project's about. And then over here on the right side is the email thread that it was on. So you don't just see the thing, you see the entire discussion around the thing. So it doesn't matter how long ago this thing was, you're brought back into the conversational context that it came out of. You're not looking at things in isolation. And so speaking of context, you'll notice that when I select some of these, so for example that one, some of its neighbors highlight in yellow. That's because they're on the same email thread. So the map is stable, these labels don't shift around, but we show related things by highlighting relevant subsets within the stable map. So for example, over here, when I select this guy, you'll see, okay, there are 3 more contributions to that thread, and then something else a few months later, and that just kind of pops out at you. And we use the same sort of technique of highlighting in context to show search results. So over here on the ground, there's a spot marked search, and I point to that, and I can say, what has Toby posted? And so we see that, right? Or what has Glenn been up to? Searches for Glenn. Or Toby and Josh have been working on a project called Apparatus, and now you can find the apparatus-related thing that you were looking for. So this way of showing search results is very different than, say, the Google style of a list of 10 things which are just totally decontextualized, where you can't see any relationship to other things or to any larger space. What we're trying to do with this project and with a lot of these other projects is to create a stable, persistent map of the space and to always be seeing things in that context. This is the Serengeti, a Hypercard-like dynamic diorama. As you laser each animal, it makes it sound. This diorama was put together over time in a shared physical space. Because it was out in the open instead of in a computer screen, it naturally attracted collaborators who worked together side by side. Eventually, everyone in the group put at least one object into the scene, some simple and some with advanced behavior. Here I'm going to add a new animal to the scene. I bless it by pointing to its 4 corners. And now I record a sound for it with my voice. I save the sound file and give the object the name of the sound file I just recorded. The label on the wall to the right is the wall audio player. That's the object that's watching the animals on the table and playing their sounds when they're selected. You can put your face on the bunny. A program for recording a stop-motion animation is attached to the bunny itself. I bring up the bunny in the inspector, run its program, and record a new animation. Now I'm going to add a chameleon to the scene. The chameleon is going to live on the leaf of a plant. After blessing the chameleon, I attach a 4-line program to it, which will make it change color when a color swatch on the wall is selected. Here I'm pointing at different colors in the color palette, and the chameleon is changing color. Here I'm using that same color palette to paint a picture on the wall above the Serengeti. The painting program is attached to the wall itself, and I could edit it by bringing the wall up in the inspector. The research group would occasionally watch movies together, and we'd sometimes experiment with ways of augmenting the viewing experience or the discussion afterwards, and sometimes those experiments would use Hypercard in the world. When watching this film, everybody had a laser pointer, and when you lasered the screen, a vote counter would go up. If enough people voted, we'd pause the movie and have a short discussion at that point. We also found that it's just fun to watch a movie with laser pointers. For watching this talk, we hung up printouts of the slides to the left of the screen. The black moving bar you see is the playhead. It shows what slide we're on and our progress through it. At any time, a viewer could laser the screen and it would leave a bookmark at the current position in the form of a red bar to remind the viewer of a point that they wanted to bring up during the discussion afterwards. The act of bookmarking was visible to everybody. We watched this video with a shared annotation prototype and later made this poster transcript with our annotations on it. You can laser a thumbnail on the poster to start playing the video from that point on an iPad. I found that the group's annotations would act as landmarks in the map. I would use the poster by spotting someone's comment, lasering it to play the video from there, and then listening to the video while scanning the poster for a connected or related idea, usually in someone else's comment. I then jumped the video to there and scanned for the next connection. We held a game jam in Hypercard in the World, in which members and friends of the research group spent 3 days making laser-powered games in physical space. Many of the participants had never previously made anything in the system. We started with a short tutorial, including sample code running on the wall. By the end of the 3 days, 10 games were made and presented. Mole Tank is room-scale competitive whack-a-mole for 4 players. Each player chooses a color and runs around the room lasering moles of their color.
No! Quit changing sheep! Yes!
In Laser Socks, you attempt to laser your opponent's socks, while dancing to avoid them lasering your socks. As your socks are lasered, your life bar fills up. In Standoff, you wait for the music to change, then spin around and attempt to shoot your opponents. Tamagotchi Island is a long-running game where over the course of the day you catch fish to feed the inhabitants of the island. In laser trains, you build a physical train track in such a way that the laser pointer taped to the train lasers a sequence of stars on the wall.
If you build a train track and try and make it hit all the stars.
Pong is a room-scale Pong game where, when the ball goes off one wall, it emerges on another wall elsewhere in the space. In the game, We'll Get Through This Together, players have to collectively bounce a laser off of handheld mirrors to restore health to sick flowers. In contrast to a normal screen-based game jam, every game that was made here was multiplayer. This wasn't agreed upon in advance, it was just a consequence of designing for the real world. Games intended for 2 players worked even better with 4, 6, or more people joining in.
Keep going.
And unlike what we typically think of as social games, most of the games here are centered around body movement and physically interacting with other players. Also, most games generated very rich experiences with very simple code.
If you build a train track.
This is BigBoard, and BigBoard is the implementation of the Hypercard in the World system. So Hypercard in the World is our authoring environment for creating dynamic spatial media, such as those large active posters made out of physical things. And here it is implemented in itself as a large active poster made out of physical things, right? So each one of these things is an object in the system. And over here in the inspector, I can point to any one of them and bring it up, right? So these blue pieces of paper have code attached to them. And if you got close, you could actually read the code. It's printed on it. And then these large pieces of foam core have data collections. So the way the system works is up here, this bit of code is looking in the cameras and looking for bright dots. So we have cameras in the ceiling, and the exposure is all the way down, so they see black most of the time, unless there's something super bright, like a laser. And so you can see this camera is seeing a point at that XY position. So this bit of code is dumping the results into this data collection. If there are 2 bright dots, then it sees both of them, right? And then maybe if the dot's over there, then it sees in a different camera. So then this code is mapping this collection into that collection. So here we have dots in a camera, and then here it's kind of creating a unique tracking document for each one, so we can track each of these dots individually in case multiple people are working together on the same board. And then this code is looking at that and doing a hit test. So this is a point in camera space, and this is saying, is there any object at that point? And if so, we translate it into a point on that particular object. So we can see here that I'm pointing at the big board. And if I go over here, I'm pointing at the strip above bookshelf. And that's what it says. And then I can point at the wall above bathrooms, or I can point at the seeing spaces poster. Right? So these are root objects, meaning that they're defined by where they are in the camera space. And then objects can contain objects inside them. So this is doing a hit test within that object to find contained objects. So you can see here, I'm pointing at the lasered objects object, and there it is, lasered objects at depth 0, and then its container, big board, is behind it at depth 1. And so anything I point to here is going to show up in this collection, right? I'm just pointing around the room right now. So you and I can look at this collection and see what the system thinks is being lasered. The code that's running does exactly the same thing. The code watches the same collection, sees the same data, right? So when you're writing the code, you don't have to imagine this data in your head. You can just see the data that's flowing through the system and write the code to respond to exactly what you're seeing. And I'm going to get back to that in a bit. So many things are watching this collection. One of them is over here, the selection machinery. So we have this way of selecting objects. This is just a crosshairs thing that I use to see how far off the calibration is, right? But here I've selected it, and this is a collection of selected objects in the room. The crosshairs is selected. So one of the books in the library is selected. One of the labels in the research gallery is selected. And then the way that processes work is you can attach code to objects, and when that object is selected, that code runs. So that's what these things are doing. They're watching this collection, and then when an object is selected, if there's code attached, it turns into a process. And so these are daemon processes which run in the background, And these are illumination processes which can draw on objects. So you see this crosshairs has an illumination that's running. Its target is a big board, so now it can draw on the big board. And that's exactly what it's doing, right? If I deselect it, now that process goes away. So what this is a kind of map, right? In the same way you saw a map of a book, or a map of video, or a map of research work and emails, this is a map of a software system. And it also is functioning as the working implementation of that software system. So I think there's a couple of interesting things here. One that we've noticed is that someone can come in and just kind of stand here, play around with this, watch the data flowing through the system, maybe inspect a few things, and they'll be like, okay, I get it. Like, I understand how this works. Some people might even say that it's obvious and trivial. And why did you have to make this big board for a system that's so obvious and trivial and simple? And I know that it's not obvious and trivial because the previous version of this was not a big board. The previous version was code and text files. And I even had a lovely full-screen database viewer where you could see all the data and you could read captions that kind of described what the data did. And nobody understood how it worked. With this thing, everyone around here understands how this works, even if they don't care, right? Because you walk past it every day, you overhear people talking about it with other people. It's part of the environment, and you kind of can't not understand it. So that's what happens when you give a system the room that it needs to really represent itself and express itself, is that it go from seeming opaque to seeming trivial and obvious. The second interesting thing about this is the degree to which everything is spatialized. So in the system, every bit of code and every bit of data has to live on a physical object. It has to have a place where you can get to it and see it. So if I want to change how selection works, for example, you come here, you inspect this object, because that's where the code for selection is. It's not floating in some GitHub repository. It's not in some icon that kind of scrolls through your screen and disappears. Conceptually, the code is attached to these atoms right here. If you want to add a camera to the system, it goes in here. If you want to add a projector to the system, it goes in here, right? So this is a very different way of thinking about a software system. It forms a very concrete map where you know where everything is, and that map is shared with the other people that you're working with. Everybody kind of agrees on where everything is. And so there's a very different feeling that you get when you're working in the system and pointing to these things and knowing where everything is. And I found that feeling is kind of hard to express if you haven't really experienced it yourself. So now I want to talk a little bit about what constitutes an object. So how do objects work? So to start out, we can take a look at that little object in the corner here. This is just a little bouncy ball simulation that I made. I can bring it up in the inspector, and maybe I can want to duplicate it. So I point to somewhere on that far wall over there and hit duplicate and draw a little bounding box, right? So now we have a copy of that object up there, and I could change that copy and say maybe I want 40 balls instead of 20, change the code and save it. Now I have different code running up there. So the objects don't really care what physical machine they're running on. They don't care what projectors and cameras are involved in running them. The entire room is kind of a unified computational space, and all the objects can see and respond to each other no matter where they are. Now let's try blessing an object from scratch so you can really see how these things are built up. So I just put a sticky note on the whiteboard, and now we want to bless it. So that means pointing at the four corners, like so. And blessing does exactly two things. One is that it creates an identity for the object. So now it has a unique ID, and we can give it a name, like that. And then it also gives it a location attachment. And in this case, it's a location and container attachment. And so that says where it is within the big board. And if we were to inspect big board, you'd see that it has location attachments, location in camera and location in display, which say where it is within some particular camera and some particular projector space. So the model here is physical objects with virtual attachments. And so some of the other things we can attach to objects are data. So for example, we can make a little text file here. And now this file is attached to the object. Other objects can see it. And we can even link to it on the web. So this is a way that objects can present web interfaces to themselves if they want to. Is you just attach an HTML file to them, and then you just inspect them and link off that file. We can add state to an object. So the objects on Big Board, for example, had collections attached to them. We can also just add a simple variable, like so. And then other objects can see this variable and respond to it and whatnot. And we can add code to an object. So I attached an illumination, and the object is selected right now, so this is currently running. So for example, I might say background color equals red, and it looks orange right now because it's red being projected on top of a yellow sticky note. And we could, let's say, add some text, like that. Now say we want to make it respond. So maybe when the laser goes inside this object, we want it to turn green instead of red. So how do we do that? Well, as a human observer, you notice that when the laser goes inside the object, that object appears here in the laser to objects collection, right? And so maybe you write the code exactly the same way to notice exactly what you're saying, which is when I'm inside this collection, I'm going to turn green instead of red. So paste in a little bit of code to do exactly that. Basically watch the laser to objects collection, and if I'm inside it, then I turn green instead of red. And let's try it. When the laser goes inside, it turns green instead of red. So that's what you get from having this kind of total visibility, is what the object sees and what the human sees are exactly the same thing. So when you're writing the code, you don't have to imagine this data over here in your head. You're seeing the data, and the code is seeing exactly the same data, and you can write the code accordingly. So there's one more thing that I want to mention. You saw that you could attach state to objects in the form of collection attachments and variables. That's in fact the only form of state in the system. So all state has to live on some physical object where you can get to it and point to it and see where it is. And that's even true for the object metadata, which defines what the objects are in the first place. So over here, this is the identities collection, and this has all the identities for all the objects in the room. So this here is the sticky note that we just blessed. Here's its identity. And then here's the attachments collection, which have all the attachments for all the objects, which make them what they are. So the meta system is just as physical and spatial as everything else. And these are just ordinary objects. You can bring them up in the inspector, you can edit them. And other objects can see these collections and edit them as well. So anybody can bless new objects and change object structure. So there's no special privileges, and everything is equally visible.
The Hypercard in the World project originated with the yearning to see context. Initially, we just wanted to see all of our emails and see all of the projects we had done. But we also wanted to see the structure of the book we were reading, or the structure of the video we were watching, or the structure of the system we were building. And you don't need computation to see context. A well-designed poster will get you a long way, as long as you give it the space that it needs. People have been representing and communicating ideas using physical media for a very long time, on pages, posters, shelves, walls, panels, game boards, models, spaces. These things all take however much space they need. They're persistent, stable, tangible, easily handled and organized. They're all multiplayer by default and establish common ground among everyone present. Here's the central question that Hypercard in the World provoked. If we believe that computation can enhance our ways of representing and communicating ideas, what form should that computation take? Does it really mean replacing physical things with an array of pixels? Or can we just sprinkle computation as needed on top of these wonderful physical things? Because if a well-designed poster gets you a long way, a well-designed poster with just a few lines of code opens up whole new worlds. Compare this to conventional computing today, in which browsers and operating systems essentially try to simulate a kind of virtual world of text and images that you click on. The computational complexity of doing this is overwhelming, which means that almost everyone has to be a user of these systems rather than creating computational systems for themselves. And doing it this way never fully works. Hypercard in the World suggests a way of moving forward with computation that is accessible and human scale. Hypercard in the World was a research prototype. It served its purpose of giving us a glimpse of this new way of using computation to represent and communicate ideas. And at least for me personally, I felt like I had been freed from the prison of the computer screen, and I had no intention of going back. Like any good prototype, Hypercard in the World brought up a lot of questions that it couldn't answer, and over the next year or two, the group made further prototypes to explore these questions. One big question is about using our hands. Laser pointing is okay for referring to things far away, but when objects are up close, how can we arrange and manipulate them directly with our hands? How can we work together in a shared space with everyone seeing what everyone else is working on? How can we create programs without a computer screen? And if we're able to move objects with our hands, could objects even be programmed to move themselves? All this work culminated in RealTalk. Like Hypercard in the World, RealTalk is a computing environment in which programs run on physical objects, but it doesn't just give us a glimpse of a new world, it lets us actually live in the new world. RealTalk is completely built in itself, and we do all of our day-to-day work in it. It's been years since I've written a computer program inside a screen, and I don't expect to ever do so again. Dynamic Land is a community space we formed around RealTalk, in which hundreds of people of all kinds, artists and scientists and teachers and students, use RealTalk to represent and communicate their own ideas. And in a close collaboration with a bioscience lab, we've been doing real cutting-edge biomolecular design using computational pieces of paper and posters and game pieces and playing cards and test tube racks and, even still, laser pointers. You can find more information about this later work on the Dynamic Land website. Hypercard in the World was one early prototype pointing the way. Thank you for watching.